Hello, everyone. Welcome to the webinar, Are Your Legacy PDUs Putting You at Risk? Today's webinar is sponsored by Raritan. At this time, I would like to introduce our speakers. With us today is Andrew Donahue. Andrew is an analyst at 451 Research. He is a member of the Datacenter Technologies and Eco-Efficient IT Practices at 451. He has authored major reports covering data center management, renewable energy, IT power management, and data center cooling. Andrew represents 451 at industry groups, including the Green Grid Forum. He also works closely with the Uptime Institute, a division of the 451 group. Also with us today is Brian Beckwith. Brian is a National Account Manager at Raritan. With almost 15 years of experience in data center power distribution, Brian is well-versed in smart power chains and how best to monitor energy consumption, capacity, and environmental health in cabinets. He also guides customers on how DSIM, Data Center Infrastructure Management Software, can help meet the needs of multiple stakeholders and deliver more responsive data centers. We're going to start our webinar with Andrew giving us a high-level view on what is going on in today's data centers. He'll be sharing data on the latest trends and covering the increasing pressure to compete on efficiency and agility. He also will discuss resiliency and risk reduction and the need for monitoring and control in data centers. Then Brian is going to address the question, are your legacy PDUs putting you at risk, by first evaluating basic legacy PDUs. He'll discuss best practices and benefits of using intelligent PDUs. And then Brian will share his 1U Brian chain design theory, as well as a number of helpful tips. We'll end our webinar with a Q&A session. If you have any questions for our speakers, please feel free to type them at any time in the question box on the webcast screen. At this time, I would like to hand things over to Andrew.
Thanks, Susanna. So just a reminder, my name's Andrew Donahue from 451 Research, and I guess I'm the warm-up man for the main event here, which is Brian. I'd just like to thank Raritan for inviting me to join this webcast and share some of the perspectives we've gleaned from our constant discussions with data center technology suppliers, but also large data center operators, including enterprise, colocation, and cloud providers across the board. So I'm going to spend about 15 minutes giving an overview of some of the forces of change we're seeing in the data center sector right now. And that hopefully should give some context to the in-depth analysis that Brian's going to give around power equipment and how to keep pace with change and innovation in technology without kind of introducing too much risk. We're going to look at issues around efficiency and agility, and also risk and resiliency. We'll then also look at how intelligent power equipment, often in conjunction with data center management software, can give data center managers the tools to tackle some of the problem issues in those areas. Okay, so looking at data center efficiency and agility first, I guess there's been an increasing focus on cost reduction and efficiency improvements over the last 5 to 10 years in the data center industry. We're kind of seeing that accelerating as the distribution of different data center types changes, as you can see from this data here. We're seeing an increasing proportion of cloud and colocation data centers compared to enterprise facilities. That means a lot of organizations are often operating some kind of hybrid data center strategy with workloads potentially spread across all three different types of data center there. That's putting pressure on enterprises to ensure that their own data centers can compete with extremely efficient public cloud providers, but there's also competition between cloud and colos around cost reduction, but also quality of service. So this slide just gives a snapshot, I guess, of how we think a typical cloud operator compared to an enterprise data center in terms of efficiency and agility. We don't need to dwell on this slide too long, but you can see that the cloud provider is usually paying less for energy, perhaps due to where it's located, which country it's in, which area of the country. It may also have kind of a power purchasing agreement with a utility or some other mechanism for driving down energy costs. They're also building sites to a lower PUE with energy efficient cooling and power provision, and that's also kind of reflected in the facility build costs. IT utilization is usually higher, so we might also expect to see higher power densities per rack. There may also be some workload shifting between servers to drive up utilization. I think the kind of takeaway from this slide is the direction of travel is to operate facilities with much less wastage in terms of overcapacity, but also perhaps less margin for error as a result. So to do that, you need intelligence from software, but also sensors, meters, etc., to enable approaches like effective capacity management. So this move from resiliency and redundancy at any cost to a stronger focus on efficiency is putting pressure on data center operators. But as we'll see later, the risk of downtime hasn't gone away either. That's still a major priority. Operators are also being asked to be more transparent about energy efficiency and service levels. For example, colocation providers may be asked to provide customers with usage-based billing and even web-based portals where customers can view power, connectivity, and environmental data. Enterprises are also being asked to provide accurate energy usage data for chargeback to lines of business, for example. Alongside that, the grid is evolving and potentially becoming less predictable and even less reliable, which is why we're seeing some hyperscalers invest in power purchase agreements, or even forms of on-site generation and storage to take back some kind of control over energy management. So basically, operators are facing a lot of pressure right now across the board, is what we can kind of draw from this. So looking at some power-related issues specifically that operators are facing, we can see that from this data from 451's Voice of the Enterprise research, that up to a third of data center operators may only be using less than 50% of the total available power in their facility. And a further third may be using more than 75% of the available power. There's different ways to interpret this slide, but it highlights the balancing act that operators have to manage between efficiency and availability and the importance of intelligence around capacity management. So for those third of companies that may be butting up against power or perhaps space limits, they'll be facing a decision around how to increase capacity in the future. There's a variety of options open to them there, including moving workloads to public cloud or a colo, obviously. But what's clear from this research is that building or buying a new site is way down the list for most operators. That's understandable given the costs involved. Millions of dollars per megawatt is usual. And most operators we spoke to would prefer to expand an existing site or consolidate IT to accommodate more space and power than build a new one. And for either of those options to be carried out effectively, operators will need some kind of sophisticated predictive management tools to help with tasks such as capacity planning and future power provisioning. So we've seen that operators are under pressure to be more efficient and agile, either in competition with cloud or with each other. However, the perennial issue of resiliency and redundancy is still ever present. And despite the focus on building inherently resilient sites, through approaches such as Uptime Institute tiers or other initiatives, facilities are still suffering downtime. I think Brian's going to get into more detail on this in a little while, including look at some of the costs of downtime. But as you can see from this slide, and the next one we're going to look at, there are a number of high-profile data center failures in 2016, which had pretty significant repercussions for the organizations involved. Some of those were down to acts of God, which are hard to mitigate against, like lightning strikes. But others were down to failures in the power chain, whether at the UPS, transformer, or transfer switch level. Some of these might have been preventable with more intelligence in the power chain. For example, PDUs that can prevent unauthorized equipment from being plugged in and help kind of reduce that human-related failures, which is according to the Uptime Institute, one of the main causes of failures in the data center. It's also important to note that, the data center isn't a static system. New technologies are coming down the pipe which impact resiliency, such as building more redundancy and availability into the IT layer. So physical redundancy becomes perhaps less emphasized. Other approaches could include use of distributed rack-level UPS, which is one of the features of the Open Compute Project designs, which are kind of common to these hyperscale operators we discussed earlier. And as I touched on before, we also expect to see more integration with multiple energy sources and operators taking more control of energy distribution and even storage. However, doing those things has to be managed efficiently and intelligently, and will require improved instrumentation, monitoring, control to do so. So the common thread here is that developing more efficient but reliable sites means operating them closer to the limits, but without surpassing those limits, which requires better monitoring and control of data center infrastructure, both in terms of the IT and the facilities infrastructure. And we believe that data center management software, combined with intelligent hardware, sensors, meters, PDUs, other devices, are kind of fundamental to achieving that improved monitoring and control. So I guess most people in this webcast will probably be aware of data center infrastructure management software and have a view on it, but essentially DSIM can be used to aggregate facilities and IT data and turn it into an actionable intelligence. However, Brian probably going to attest to this. DSIM's probably gone through some difficult times in terms of perception. There was a lot of skepticism around the capabilities of DSIM tools versus what suppliers promised they could do. I think some of that skepticism still persists. I expect, even from people listening today. We may get some questions on it later. However, we think DSIM is moving to a more mature phase now, and products are more robust, scalable, and usable. And kind of testament to that is the interest that we're now seeing from commercial data center operators in DSIM, both as a way to more effectively manage their own sites, but also provide services to customers. And as I mentioned earlier, building portals based on data from DSIM, building management systems and other sources, and making that available to customers is seen as a key differentiator for a number of large colocation providers who are kind of investing in off-the-shelf products, but also in some cases even developing their own from the ground up. And as we can see from this schema, we see several levels of DSIM functionality. There are basic DSIM functions based around aggregating, normalizing, analyzing data from data center infrastructure equipment. Those basic DSIM functions include IT asset management, real-time environmental and power monitoring, as well as capacity management and forecasting. But, we're also seeing DSIM data increasingly married with IT, including IT service management data and data from business applications, to give a kind of more holistic view of the facility. And that's approach we call data center service optimization, or DSO for short. And combining facilities data with IT and business apps brings us closer to the idea of a kind of more automated and even, along the lines, kind of self-correcting data centers. But that's probably the subject of a different webcast and something I won't get into too much detail today. But I think it's interesting to note that obviously the DSIM system is only as good as the data feeding into it in most cases. I'm not going to dwell on this slide too long, as Brian is going to provide more depth and expertise than I can in different forms of intelligent PDUs and the importance of a more intelligent power chain generally. But that's only going to become more important as more data centers we think become built for purpose. And by that I mean moving away from generalist, perhaps inefficient, over-provisioned facilities of the past to sites which may be optimized around specific sets of workloads, as in the case of hyperscales, or perhaps these kind of new generation of edge data centers that we expect to emerge. So to round up, I think the pressure that data center operators are under which we discussed earlier in the webcast, there are tools out there that can help meet those demands. Whether it's a need to provide accurate energy use data to internal or external clients, or predicting future power, cooling, and space capacity. But it's also important to say that there isn't a magic bullet out there, and technology is only as good as the business practices and processes that surround it. But as I think Brian is going to demonstrate and discuss, making the right technology choices can help to reduce risk and improve productivity and improve efficiency. There's a wealth of choice out there in terms of, just in terms of smart power equipment alone. So it's important to make sure that you're making an informed decision around that. So I'm now going to hand over to Brian, who I hope is going to put a lot more meat on the bones of some of the trends and technologies I've highlighted here. And I'll get back to you at the end of the Brian session for some Q&A and discuss some of these issues further. Over to you, Brian.
All right. Thank you, Andrew. Appreciate that. Good afternoon, good evening, and good morning for some of you out there. Thanks for joining today's webinar. My name is Brian Beckwith, National Account Manager for Raritan. So today's topic, I'm really just, I'm going to hit are your legacy PDUs putting you at risk, between an intelligent PDU and a basic PDU, kind of cover features, benefits, et cetera, et cetera. So start off with the first slide here, a simple definition of legacy PDUs. Some of the terminology, vernacular that you hear out there is basic, or no intelligence. You can see the illustration there. It's pretty much just a straightforward power distribution unit. So this is really just an open-ended question, just kind of like food for thought, start the webinar out and just give you some things to think about. We talk about data center risk. So one question you can ask yourself is how much money would a rack power outage cost your company? And then another question you can think about that is, what is your worst case scenario? Hold on here. My apologies. There it goes. Okay. Risk associated with basic PDUs. So over-reliance on BMS or building management type systems. So the issue with that is traditionally with basic PDUs, there's really no metering, there's no metrics coming off of that. So the reliance is maybe back at an RPP, which is more of an aggregate of typically just current levels, maybe voltage. And that's about it. So it's really more just an aggregate level of branch circuit type monitoring. The other big problem with basic PDUs is what we call blind equipment commissioning. So in an IPDU strategy, traditionally you have your A and your B feed in the back of a cabinet. It's essentially to identify that each outlet is numbered and labeled. Some cases they'll have colored cords, colored chassis to be able to identify the power chain. The number one problem that I see in the data center is what we call blind plugging. What that simply means is essentially cross-circuiting. So if you have a server going in the back, it'll have redundant power feeds, an A and a B power feed. Blind plugging, in some cases, maybe they plug both of those power feeds into the A circuit and not one into each other. So tedious, costly power reading. So I'm going to digress into a little story here. 20 or so years ago, when I first got into the data center industry, I was at a data center in Carteret, New Jersey, and I noticed there was a gentleman there, and he had the floor suctions, and he was pulling up the tiles. So I walked over to him, and he was an electrician, and he had a metering donut in his other hand. And so I asked him, I said, why are you pulling up these floor tiles? And he said, basically 2 times a day, he has to stick the donut underneath the floor. He's got to meter the circuits that were running up into the cabinet. And he looked at me and he said, if you could take this meter and put one of those basic PDUs, you'd make my life a lot easier. So that was 20 years ago. That same still model, that applies today. So no access to rack level data, again, which is very straightforward. If you have a basic PDU, there's no intelligence, there's no Ethernet port, no SNMP protocol, any way to pull or aggregate any type of data. You can't do that with a basic PDU. You can do that with an IPDU. So hard change and workflow management, and this kind of segues from what Andrew was talking about, really for the decent stuff. So as more clients are starting to migrate to the enterprise, to the cloud or colo, the decent strategy is really coming into play more and more. So a lot of customers are really starting to look at what we call asset management. So be able to take, tag, various devices inside a cabinet, and you could do that with an intelligent PDU. There's a way to track that. You could segue the information through an iPDU and then upload it to a decent software. With a basic PDU, you cannot do that. So one of the biggest problems that I've seen, and this is very common out there, with a basic PDU, there's no LED or LCD at the screen itself locally. So we get into these, you go into colos or enterprise would have build-outs, and they're doing the rack and stack, and they're starting to power up the gear. The person that's doing the commissioning, powering up the servers, needs a local display, basically, specifically for three-phase. He starts checking phase balances, make sure that all the breakers are in sync, et cetera, et cetera. So that's why a data screen at the rack level, to me, is very, very important. Okay. So how does your data center look with basic PDUs? So the risk is high, power data, none. Infrastructure insight is none or very little because you do have a BMS system there. Data center management is very difficult because it's an aggregate of branch circuit data. Future-proof, there really is none. So overall, when I say very high total cost of ownership, that's an overall strategy. We'll get into that TCO versus an PDU also. Okay, colocation deployment. So how to ensure the best value for your colocation employment. There's still in the marketplace, somewhere in the 40 percentile that a lot of colos still use basic PDUs. And it's just more cost than anything. They kind of leave it up to the client. Do they want to use intelligent PDU, et cetera, et cetera. So what I say to the client up front is, you have to look at the business model of the colo. Some colos will charge you full circuit. And what I mean by that is, traditionally the most common circuit is an L630. So you have two of those going in the back of the rack. Some colos will actually charge you the full 30 amp circuit load. So with a basic PDU, there's no way to get any meter or metrics off of that. Other colos will give you, they'll put some type of donut at an RPP level and then give you sort of an aggregate in that regards. But with an intelligent PDU, the granularity of it now, you can go all the way and meter at the outlet. You have that ability to meter that data. You also have the ability, if you use some type of software system or DSIM, you could do bill back reports. So you can run a 30-day report, come up. So if you're looking at 230 amp circuits, maybe you're only utilizing 15% of that circuit. You have the ability to go back to the colo provider and say, look, here's my IPD data. Here's what I'm currently drawing, and then you can come up with better terms. All right, here's a general polling question, and I'll give everybody about 20 seconds or so to answer this. So how much do you think 1 minute of downtime costs on average? So you have four choices. There's 15 to 20,000, there's 10 to 15, 5 to 10, and 1 to 5,000. Give everybody a couple more seconds here. All right. Okay, cost of downtime. 1 minute of data center downtime costs on average $8,800. And that's US dollars. So think about that for a minute. That's just 1 minute. So what if you calculated 1 hour, 1 day, 2 days, et cetera? So, these are the things you have to think about up front when you start looking at, your data center build, whether it's a greenfield, colo, edge, cloud, et cetera. These are some of the metrics you really start to have to consider. And what I like to say to clients is, don't become a firefighter. That's the thing you want to avoid. There might be a little leg up, a little upfront work initially with the IPDs to get them all set up. But I'll tell you, the last thing you want to have, have your CTO calling you up and saying, hey, why is my network server down? That's not a good day for anybody. Okay, feature set differences, basic versus intelligent PDUs. So this is kind of segueing. Basic power delivery, the illustration at the very top, as you can see, it's just very straightforward. Your power distribution delivery, there's really no metrics that are coming off the basic PDU itself. So if you look at the bottom illustration, kind of gives you a little more detail. Some things to start to think about is circuit breaker, base type metering. Does it have an onboard display, whether it's an LCD or LED? Metering accuracy is important. There's two ways to look at metering accuracy. You'll hear a lot of people talk about a plus or minus 1%. Is it plus or minus 1% on the LCD, and also plus or minus 1%, on the output at the outlet level. So these are some certain questions you want to ask your IPDU provider. How granular do you want to get outlet level metering? What's the accuracy rate there? Is that plus or minus 1%? What type of metering chips or capabilities do they use to aggregate that data? Also, inlet metering. So advanced power management and data center infrastructure monitoring all play a key role into this. All right, key benefits of intelligent PDUs. So reliable. So reliability by design. So this is a very good question. If you're starting to look into your next data center build, these are some of the things you want to start to ask for various IPDU manufacturers when you go into your selection phase. So reliability by design. So things you want to look for is, the construction of the PDU itself. Do they use a steel chassis? Do they use aluminum extrusion? Use like a wire bus terminal where they clamp down the outlets and then they have wire buses in between? Or do they use some type of circuit board, where they cold solder the receptacles on there? These are very important because this leads to reliability, the PDU itself, and you can ask about a mean time between failures or MTBF information. But the key takeaway from this is, you start getting into temperature ratings. Most of them are typically 60 C, some are a little less at 45 C. But to achieve 60 C, that's where the heat dissipation really has to take place. So if you look at a chassis of an IPDU, does it have punched out holes in the side, or is it a full type of chassis? It's embedded. You don't have to worry about any kind of particles or anything getting inside of that. So again, that prevents downtime. There's also advanced alarming. So advanced alarming is, again, don't be that firefighter. You could preset threshold data, with defined events. So you ask yourself, what's important to you? Heat's important, temperature ratings. You don't want to overload a circuit. Maybe you set a threshold for maybe 50% on all the circuit breakers. There's alarming capabilities. Locally on a PDU, you want to make sure the PDU will alarm, the LED or LCD will flash for you. And also whatever protocol, most common is SNMP. Does it support, BACnet or Modbus and things like that. So rapid remediation is essentially, if there is, you have the ability to go and put that fire out before it becomes a full fire, and that's remediation recourse from that. So easy to use, rapid deployment. So you start looking at models. Traditionally you look at your specifications. What type of circuits? Is it single? Is it three-phase? Is it 208, 415? So you want to find something that's easy to use, easy to install in the back of the cabinet. User-friendly interfaces. So when you start looking, basically at the metrics and the data, you want to make sure it's easy to be able to go into it, whether you go in through HTML browser or you're going to aggregate that data via SNMP back to some type of power or a DSIM system. Cost-effective networking. Another strategy. So I travel pretty much throughout the country, and every area of the country is a little bit different. And what I mean by that is Ethernet addresses, IPs, sometimes it costs clients money. Some cases it could be $100 an IP. I've seen other cases where it's a couple $100. So the question comes up, how can I mitigate the IP costs? If you have a large deployment, I'll give you an example. you've got 100 cabinets, you'll have 200 IPDUs in there. You're talking about 200 network addresses. So we run into situations they want to basically streamline or minimize the number of IPs. So questions to ask, can you cascade or can you daisy chain PDUs? Can you, simplify down to one network address? How many PDUs can you manage off of one network? Sometimes it's a one-to-one scenario. Sometimes it's 4. Other cases it could be 8. Also, if your business model, if it allows for security, they'll ask if they have Wi-Fi options. Scalable Wi-Fi stick that can go in there. You can take an antenna and stick it on top, and you might be able to aggregate, 50 PDUs off of a WAP address. Straightforward decisions. And again, this helps you make part of a decision-making process. So you look at risk, reward up front, CapEx cost, on the back end too, the network, the setups, and things of that nature. And that's actually one thing I just thought about here. It's setup features. You make an intelligent decision, you decide to go with an IPDU. Typically, if there's any data center managers or guys who've ever spent time on the data center floor, any kind of Cisco gear, servers, PDUs, et cetera, taking the old crash cart, going in, logging in, setting up a putty session, the good old days, it would take you, it could take you several minutes to 5 minutes to set some of these devices up. So what you want to look at, is there a way to streamline that process? Do they have like a USB quick setup program? Do they have a TFT type server? Does it look at the DSIM software? Does the DSIM allow you to bulk threshold or push bulk data out, in one configuration file to make your life a little bit easier? So future-proofing, advanced engineering. So this is actually very critical. So again, when you start looking at the manufacturers of IPDUs, what type of capabilities do they have? Are they global? If you start looking at power specs, we see a lot of enterprise clients here in the States, but they also have, other sites that could be colo or enterprise in Europe, in Asia, Canada, Mexico, South America, et cetera. So you want to look for a global provider. That's absolutely critical. The other things to look for, is the manufacturer, are they going to give you 10 SKUs of 10 models and that's it? More, I hate to use the word cookie cutter, but that's sort of the approach that they take. So it's not always the best fit for your application. So is that IPDU manufacturer willing to customize? Color chassis, color power cords, things to really think about outside the box here. And this helps the perfect fit to the rack. And again, this is another area that I see. I deal with multiple cabinet manufacturers in the marketplace. And some of you can attest, not every cabinet guys are the same. You might spec in a 44 or 45U cabinet, it's 24 wide, 46, 48 inches deep, but all the mounting is completely different. And it's just the manufacturer and the way they weld it, put the units together. So, some of them, typically an IPDU has a black toolless button. It's a round button, and they call them teardrops in the back of the cabinet. Some of the teardrops will allow you just to put the IPDU and drop it right in. Others you need special like mounting type brackets and things like that. So from our perspective, you always want to look at the mechanicals. You don't want to run into a situation where, you have a 42U rack. Internally, you only have 76 inches of usable height, but you want to go into an IPDU that's 7, 8 inches tall. So you want to try to avoid situations like that. And this, again, helps create a sustainable power chain design and high interoperability. So I'm going to segue into another story here about interoperability and why this is important. And this goes into what we call the APIs, open APIs in the MIB files. And a lot of people, quite frankly, when you get in this, they don't really think about it. And this is really more, the hardware, the software guy, engineer guys kind of really start to look at this. But these are some of the things you want to ask up front. And I'll give you a real-world situation, an account that I was involved in 2 years ago. We were running it against one of our competitors, and side by side, the client was having a hard time making the decision, from a pricing point, features, benefits, et cetera, et cetera. Both of the PDUs were pretty much on par with each other. So what he asked for, he said, I have a third-party DSIM provider that I work with, would you, both of your companies, be willing to send some evaluation units down there? I want to have that guy validate and test them. Not a problem. So we went in, sent the PDUs down to the decent provider, and went back. I went on site a couple days later just to do follow-up, and basically sat down, and he looked at me, and he said, here's the scenario. He goes, it literally, from out of the box, it took me about 1 hour to get your MIB files integrated. He was like, very easy, open MIB files, easy to use. He said, your competitor, I'm still having a hard time integrating those MIB files. So when I say MIB file or open APIs is important, and we won that account based on a MIB file. So it is absolutely important to ask those questions. Okay. There it goes. Okay, sorry about that, folks. So reliability, different metering levels to prevent downtime. So precision enables confident and reliable IT equipment commissioning. So this, I sort of touched on this a little before, but these are, there's typically 4 classes of IPDUs that you start to look at. Everybody's business model is going to be different. So, the most common one is the network meter. So we meter at the inlet and meter at the breaker. The step above that is outlet switching. So what's very straightforward explanation means you can turn the outlets on or turn them off remotely. Also meters at the inlet, meters at the breaker. There's also a step above that, it's outlet metering, meters at the inlet and breaker, and then what I call your Cadillac or BMW class, that does everything. So that's outlet metering, outlet switching, meters at the inlet, and meters at the breaker. So I always harp on the metering accuracy, plus or minus 1%. So what we call real-world loads, not just in the lab, and all power load types, not just peak loads. So your average loads, your peak loads, et cetera. So the plus or minus 1%, I've seen some scenarios out there where a lot of guys will claim plus or minus 1%. They run some tests, and it might be 4%. They might hit that 1%, and they say, oh, we can do plus or minus 1%. So it's really, if you think about it, it's more continuous type stuff. So again, you want this to show on all interfaces, whether it's the LCD, LED, or a third-party type of software. Okay. So easy to use, managing the data center environment. So the other takeaways you want to have from this, we're sitting there focusing on the power management. There's also environmental things to also take into consideration. So the other question is, most commonly, most IPD manufacturers will offer temperature, humidity, but do they offer more than that? So that's kind of some of what I call the scale of the IPDU. What type of controller does it have? Is the controller more passive? It's just going to pass data through, or is it active? Does it have an active processor? Can you pull data? Can you buffer data on the controller itself? So you start looking, your standard temperature, humidity, but is there other type of sensors too? Because as I always say, day one, you've got this in mind, but as everybody probably on this webinar can attest to, there's always changes happening, add moves or changes. So what you think is good now, you want to future-proof it for 6 months or even a year, because it's something that always pops up. So having a scalable IPDU that can meet the demands of today and also for the future is absolutely critical. So, if you're concerned about water detection, smoke detection, door alarm, door ajar, unlocking sensors, do you want to put a web camera in there? For security purposes in a colo. So these are some of the things you want to ask up front. What's the scalability of these IPDUs? And to the chart on the left is the ASHRAE standard, which I'm sure pretty much everyone's familiar. So typically, like an ASHRAE, what can an IPDU offer you? Do you have the ability to do a sensor top, sensor middle, sensor bottom? You could do it in the front door and the rear door and try to check the delta of temperature ranges, and that just goes in combination with ASHRAE standards. Okay, so future-proof, maximizing reliability and capacity at the rack. So if you look to the illustration on the left, it shows a cabinet. And basically the question is, capacity, growth, and management. And it's, can you plug in more equipment? So typically, your server clusters, your pods, your nodes, everybody's got a different acronym now for when they start to do cabinet build-outs. Typically, your low density is 8 kW or less. That could be single phase, three-phase, like an L2130 goes up to 8 kW. The 1 and 2 servers, I call them Pi servers, and this is typically the IDF or MDF in the networking stuff. So high density, typically that's your blades. It could be your Cisco chassis, your compute clusters, HPCs. That's typically 14.4, 15 kW and higher. So that can, at 208 volts, you can do it at 408 or 400, 415, at 3 phases. So phase load balancing. So this is becomes very critical. So when you have your A/B strategy, especially if you start looking at 3-phase, so 3-phase 50, 3-phase 60 at 208 volt, you have there's circuit breakers. Most of them now will have 6 circuit breakers. So if you look at the A6 and the B6, you have 12 breakers. You're just trying to marry up those breakers and keep everything in balance. Moreover to that, now we're running into 415 volt, where we're running into 33 kW or even 55 kW at 415, 80 amp or 100 amp hardwired. You'll have 12 breakers. So think about that. You'll have 12 breakers on the left and 12 breakers on the right. And again, you're just trying to keep everything in sync and in phase. Circuit breaker alarming. It's actually very important because, do the IPDUs, do they offer you a way to monitor that circuit breaker? Not just walking by it and having to look and maybe the LCD or LED is flashing, but via SNMP or some kind of protocol, there's an alerting system that takes place. Circuit overload protection. Again, you want to protect the circuit breakers again, and that's setting thresholds, typically 40 or 50%. So if there's ever what I call the God forbid moment, if something went down, everything rolled over to side B, it'll be able to handle the full rollover. And again, and you can start looking at software and things like that. Does the software provide rollover reports? So you can kind of become like what I call preventive maintenance. Again, I refer to the firefighter, which you're trying to avoid. Inrush current prevention. Okay, this is very important, and I'm going to segue into another story here. So inrush current is, if there's ever an event, you had a recycle on the switched outlet IPDU. Typically, in some cases, you might get 100 amps in a few milliseconds, and you could overwhelm the IPDU. So you try to avoid that. And there's a couple ways to mitigate that. You could stagger the outlets, the timing of the outlets, and how to start up, like a graceful startup. But moreover is, what I always say to people too, is if you start looking at the switched IPDUs, meaning outlet control, is to ask what kind of factory default do those come in. And what I mean by that is relays. So you'll hear the term NO for normally open, or another term NC for normally closed. Now this is very important because, again, there's always a situation, as Andrew talked about, there's an act of God or something happens, and maybe the power resets, reconditions, or something. There's an event that takes place in the data center, and the PDU itself goes back to what we call a factory default, factory state. So if most of the PDUs come out of the box, they're typically NO or normally open. That's the way the relays are set. So if the relays go back to factory, the controller goes back to the factory state, it leaves all the relays open. What that simply means is that there's no power to the servers. So I was dealing with one financial company, and unfortunately they ran into the situation, and they kind of found out, I hate to say the hard way, but they found that out because of that very reason. So these are questions to ask up front. So here's one thing for a takeaway. If you look at, how can I mitigate that? Does the IPDU offer hybrid latching relays? So what that simply means is you have the ability now to set the factory state. So I'll give you an example. If you have a 30 outlet IPDU, maybe you're only using 18 of those. Those are critical. You could set those, keep those always closed. So if there's ever an event, the hybrid relay is always in contact, whether the controller went offline or not. Those are always in contact. You don't lose any power to the servers. You also have the ability to sequence or time the outlet so you avoid the inrush coming into the PDU itself. You can make it 5 seconds, 20 seconds, 30 seconds, etc. So a lot of scale to that. So another thing to think about too, and we deal a lot in the enterprise and colocation, what we call selectivity with upstream, RPP, and tap boxes. So everybody's starting to look at being more cost conscious, and there's some ways to look at that. So more and more now we're seeing a lot more high density. Typically it could be 50 or 60 amp 280 volt. In some applications it could be 415 at 30 or 32 amps, etc. So one thing you want to look about the IPD manufacturer, if anybody's ever seen the 60 amp with an IEC plug out there, it's the size of American football. It's pretty beefy, and it actually costs a lot of money too. So, if you look at scale in the IPDU, do I have the ability to do a terminal block to the IPDU? And what I mean by that is now you can take the whip away and the plug away, so you're reducing cost. And the caveat, though, you do need an electrician to do that, but he basically can hardwire from the tap box down to the terminal block. So there is electrician cost involved, but you're eliminating an IEC plug and an 8-gauge, a 10-foot 8-gauge whip, off the cost, times that by 2 per cabinet. There's definitely some cost savings there. So stranded power capacity detection. It's, again, very straightforward. Again, the plus or minus 1% metering is absolutely critical. What this allows you to do is to get extremely granular at the cabinet level, what I call down to the 1U. So if you start looking at that, if you have IPDUs that are maybe plus or minus 3% or plus or minus 5% or even 10% accurate, what does that leave open to you? And what I call lost revenue. So real estate equals revenue. That's my one big takeaway from that. So if based on that design, you can start maybe have an additional 1 or 2 left, with plus or minus 1%. Hey, I feel confident I can put another server in there, and depends on your business model, that server could equal revenue for you. All right, so how does your data center look with intelligent PDUs? And it's just kind of segueing back. So the risk, again, is lower. The power data is granular. The infrastructure insight is rich. Data center management is a lot easier. Future-proof, absolutely yes. And the cost, lower total cost of ownership and the high return on investment. So the one takeaway from the cost, see, that's the balance, because obviously a basic PDU is going to cost less than an IPDU. So, from a CapEx, it could be 2 or 3x. But there's a lot of analysis that are done. And as I always say, again, I always refer, don't become the firefighter. That's what you want to try to avoid. Okay. This is a general question. There's really no right or wrong answer to this, but this is more for just my, personal, trying to get some feedback from everybody in the webinar. So when you start designing the power chain for your data center, what's most important to you? Power going into the building or power from the cabinet 1U? I'll give everybody a little time to answer this. Looks like power going into the building is going to be the big winner. There we go. So it looks like 86% says power going into the building. Okay, so this goes to what I'm seeing more and more. I call it my 1U power chain, but I'm actually seeing it more and more from a lot of enterprise clients. So not try to minimize the power coming to the building, because it's absolutely efficient part of the and critical to the power chain. But what happens in a lot of cases is that they're spending, X millions of dollars on infrastructure, transformers, PDUs, and everything else, and then all of a sudden you start looking at the budget, you've got a cabinet and basically a cabinet PDU, and you're like, oh. So to me, it's mission critical. It's not a commodity. It is definitely an asset, and that's how when you start designing these power chains, you have to think of it as more of an asset. Kind of everything that I had covered before, the granularity and what kind of metrics, but if you think about the 1U at a cabinet level, the 1U is always constant. So whatever server you put in there, the power can change. The power can go 120, 208 with auto sensing, from 208 to 415. Basically the power, the formula changes. You get 240 output versus 208. So that formula will change, but the 1U is always constant. So, what I'm seeing a lot more now is that, because of what Andrew talked about before, DSIM, now you can start scaling. You can do asset management, rack elevations. You can start laying out your gear now. When you start looking at, you'll have a good idea what the power consumption is. It helps you plan more efficiently, and part of the green energy, build back options, carbon tax, et cetera. It goes into play of all that. So the key to that is the power chain load balancing and capacity control. So if you start at the 1U, you go to each outlet, you minimize the blind plugging. You don't want any of that. All your phases are in balance. Your breakers are in balance. So the power chain starting at the 1U going back upstream is extremely efficient. It just helps with the overall, the power chain itself. So I just want to share a quick 1U success story. I know we're getting a little closer to the time here, but so I was working with a financial hedge fund, and they wanted to change strategies regarding the power chain. So what they, typically they did the build, everything coming from the building, all, the whole power chain, et cetera, and they just started realizing they were having issues because they were using basic PDUs and, outages and things of that nature. So they decided to change the strategy, more focus at the 1U level. And the goal was that, and this is their term, a homogeneous power chain. So kind of what I talked about before, the level of detail, outlets matched the AB power chain, breaker balance, phases were also in sync. So what this allowed them to do, it created a roadmap, when they started looking at colos and edge and things like that, all the way down to the 1U, and they had the ability to build out that server, switch, and router roadmap at the 1U level at the cabinet. So when they went to their next deployment, for them it was rack and stack and plug and play, so from a downtime perspective it was very short. There wasn't a lot of commissioning that took place because they had a lot of the data that was already up front. The other big takeaway from that at the 1U is for them, because they use outlet metered strips, they were looking at various server suppliers out there. A lot of the server manufacturers or power supplies are pretty much, most of them are pretty much the same, 750 watts, et cetera, things like that. But what they wanted to do is they wanted to do some lab testing and do some reporting based on that, because the power bill was a big piece of their budget. So they had server, X and server Y, and they tested the power supplies for 6 months. One of the manufacturers was a little bit more efficient, like 1 or 2%. But if you start thinking about that, you got like 40 cabinets, and there's 22 servers per cabinet. You're talking over 800 servers. 1 or 2% can add up as far as data goes in the power bill. So the big takeaway from that is they could not do that with a non-intelligent PDU. All right, so I appreciate everybody's time. We're going to do a Q&A session.
Great.
And
thank you,
ahead,
Andrew and Brian. Thanks, Brian. As a reminder, if anyone has any questions, please type them into the question box on your screen. I see that we already have a few submitted questions, so let's jump right in. The first question is, for a small footprint data center, do you think that the cost of intelligent PDUs versus basic PDUs justifies the investment?
I'll take that question, Susanna. This is Brian. Absolutely. Whether it's a small data center, it could be 2 racks, or a larger enterprise, 100 racks. Having an IPDU is absolutely important, and there's a couple reasons for it. And again, depends on your business model. Depends what kind of facility is it manned or unmanned? So maybe outlet switching type of PDU where you can remote access into it. And basically recycle the server without physically having to have someone on site. You start looking at, the return on investment in the long term, you can save a lot of money in that regard. So to answer your question, yes, I believe it's very important.
Great. Thank you, Brian. The next question is, can you manage, oh, sorry. Andrew?
Yeah, I just had a quick follow-up question to Brian about, how far you've kind of taken that analysis about intelligent versus basic PDUs, and have you kind of done any sort of ROI calculations? I think you were talking about, 2 or 3 times X in terms of the cost difference, but I guess you also have to factor in some of the, some of those significant downtime costs, perhaps into your calculations when you're talking to customers, right?
Yeah, absolutely. There's a couple of ways to approach that. Whether I can talk about a retail pharmacy chain that I'm actually working with right now that actually plays into that exact question. They've got thousands of retail pharmacy stores in the United States, and each one of those stores, it's a small, what they call like a little land room or a closet. It might have 1 or 2, land racks, maybe 8 or 10 servers. It depends on the size of the retail store. When they started this build out, again, they went through UPS, whatever, servers, manufacturers, but they just threw a basic PDU in there because it kind of went to a contractor. The cost was, hey, I can get a basic PDU for X amount. I don't really need all the smarts or whatever. And that was the thought process. And, back maybe 5 years ago, that made sense. But here's what's going on today is that now they're having issues, whether it's an outage, and there's no way to get in and basically recycle outlets. So what they were looking at is the cost of, they have people that work for the pharmacy, but they also have contractors that have to sub this stuff out. So a contractor, at an average of $100 an hour would have to, get in his van or jump on a plane and go fly to wherever that site was, basically go into the LAN center and restart the gear. So if you think about it, the power could still be going on, but if you have like a notebook of some type, you ever get the spinning hourglass and the thing hangs up, basically you got to restart your notebook to, get it back to normal. Same principle there with these remote sites and the server gear. So when they did some quick math, at an average of a couple $100, and they did about 3 hours on average, it was $600 or $700. So what they did was they looked at a switched IPDU and they said, basically that was the same cost. And some of these sites had multiple, kind of repeat offenders. So you start calculating that ROI. For them, it become pretty much a no-brainer. So they'd have a 3-tiered strategy. The tier 1 is the mission critical, where they're really they have the problem sites, and then tier 2 is the less problem sites, and the tier 3 is the overall. They're going to replace basically all the stores. They're going to have a switched IPDU in there.
Right. So it's not just a case of looking at the upfront costs against each other. You've got to kind of take a total cost of ownership view of it.
Absolutely. Yeah.
Okay, great. Thanks. We have another question. Can you manage power capacity using intelligent PDUs, or do you need DSIM software as well?
Yes, you can. You can absolutely manage the power capacity. So each IPDU will have its own independent web browser. Typically, and it's secure. So it's typically HTTPS for secure, and then whatever the IP that you set to that particular PDU. Andrew touched on it, and it's a very, very great point. So the software, whatever software that you're using, it's only as good as the data that it gets from IPDUs and other devices. So that goes back again to the plus or minus 1% accuracy, managing capacity and stuff like that. So the software is really more of an aggregator. Where I see the software more in the enterprise and things like that. You can use it for small sites. It's just a simple license, for 1 or 2 devices, or you could go enterprise. It could be 100 or 200 licenses for a larger rollout or things like that. So you can get the meter and the metrics locally, but if you're looking at more of a data aggregator, you want to pull, and you're thinking more robust and stuff like that, then the software can also come into play.
Great. And thank you. And thank you, everyone, for joining, but I'm afraid that we have run out of time. Thank you to Brian, and Andrew for your presentations. For more information on today's topic, please visit Raritan.com. Thank you.
Thank you, everybody.
Thank you.